Preparation, see, it's both laboratory and industrial preparation is same. In both laboratory and industrial process, PRESS, hydrogen chloride is prepared by heating sodium chloride with concentrated H2SO4 below 420 Kelvin. So it is NaCl plus H2SO4 concentrated. Here it is less than 420 Kelvin. Okay, you'll get now here NaHSO4 sodium hydrogen sulfate plus HCl. The hydrogen chloride. See, when it's in gaseous state, we call it hydrogen chloride. Hydrogen chloride is dissolved in water to obtain hydrochloric acid.
Done, sir.
Okay, good. So now let me see my copy. Properties. Physical. See, hydrogen, chlorine is greenish yellow, but hydrogen chloride does not have any color. So it is a colorless. It is a colorless gas with strong choking odor. ODOU. Okay. So now let me start. Rubbing the board is become so problem to me. And if I rub with water, I cannot write. Then what to do? It's created a problem for me, dear. To take class. So let me write now here chemical properties. Oh, in physical properties, please write one thing. In physical properties, you write it is infinitely soluble in water. It is infinitely soluble in water. Means high amount of HCl is soluble in water. More than 750 volume of HCl, hydrogen chloride gas is soluble in 1 volume of water. More than 750 volume of hydrogen chloride gas is soluble in 1 volume of water. Please write. Now we'll go for chemical properties. So first one we will write acidic profile. Okay. So we'll write now here aqueous solution of HCl means what? That is what? Hydrochloric acid is a monobasic strong acid. So what should I write now here? HCl plus water, it will give you H3O plus Cl minus. Or what I can write? HCl gives you HClAQ gives us H plus aqueous Cl minus aqueous. Okay? This is the now second. See, we know any acid reacts with highly electropositive metals to liberate hydrogen. We will write now here. It reacts with highly electropositive. See, my students should be very good. I don't compromise with my quality of teaching. What is the meaning of highly electropositive metals? That is, we will write here the metals with negative standard reduction. Your conception will be sound with negative standard reduction potential, because we know only metals with negative reduction potential can displace hydrogen from the acid, because acid is 0.00. Lower reduction potential can displace elements with higher. So 0 is more than negative. Metals react with HCl to liberate what? Hydrogen gas. So you take right here zinc plus 2 HCl, it will give you zinc, chloride, and hydrogen. Right? Fe plus 2 HCl, it will give you FeCl2 plus H2. This is important for your exam. So let you finish and tell me, then I'll explain. Then again you write.
Done, sir.
Okay, now see here. We know iron has two oxidation state, Fe2 plus and Fe3 plus. See now. So Fe2 plus, don't write. Fe2 plus is 3d6 and Fe3 plus is 3d5. That when I'll go to truncheon metal, then you'll understand. Now between this 3d6 and 3d5, which is more stable? Which is more stable? What is the maximum number of electrons you can find in d orbital? Maximum number of electrons. D orbitals can accommodate how many electrons? See, p orbital has 3 orbitals, 3 into 2, 6. So maximum number of electron for p is 6. So what will be for d orbitals? What will be the maximum number?
10.
10. See, good. See, dear. Any element is having half filled and completely filled electronic configuration are very stable. So 3d10 is very stable and 3d5 is very stable. So between this and this is more stable. But very interestingly, dear, when you react iron with HCl, you got here FeCl2. Why not FeCl3? But when we reacted iron with chlorine, remember in the last class, when I reacted iron with chlorine, there I did not write FeCl2. I have written FeCl3. I have written FeCl3. There I did not write FeCl2. But why I am writing now FeCl2? So let us try to understand. This is there in your book also, this question. See, actually, which is more stable? This is more stable. So it loses 3 electrons. So I'll write now here, Fe plus 3 HCl, it gives you FeCl3 plus 3 H. Okay, I'll make it more clear to you. Fe solid, it loses 3 electron Fe3 plus 6. And it gives you 3 electrons. All right. Now HCl dissociates to give you H plus and Cl minus. So this H plus is electron deficient. So it will take the electron and it will become what? H. This is the story of liberation of hydrogen from acid. How many are given? 3 electrons. So I shall multiply it by 3. And this hydrogen is coming from second equation. How many it is given? 1. So I require 3. I shall multiply by 3. Okay. So now what I'll do? This. Then this. So if I write it like this, what should I get? I'll get here Fe plus positive and negative combines. And what you get here? 3 hydrogen. See, this is atomic hydrogen. Now you know atomic hydrogens are very reactive. What they'll do? They'll go for reduction. So see here. What is going to happen now? FeCl3 is going to reduce this FeCl2 because it has 2 oxidation states, this and this. It has formed this, then Fe3 plus can take maximum 1 electron to go back to Fe2 plus. So what should I write now here? I add it. So what do I get now here? FeCl2 plus. So forget about this equation. Think of this equation. See here. What you have? FeCl3 and FeCl3 get cancelled. Out of 3, you have 3 hydrogen and you have 1 hydrogen. You have 3 HCl and 1 HCl. What should I write now here? I'll write now here. 2HCl gives us FeCl2 and 2 hydrogen. If I write 2 hydrogen combines to give us what? Hydrogen. See, if hydrogen cannot give its atom, if suppose if the hydrogen atom is not being taken by others, then 2 of them will combine to form hydrogen gas. First hydrogen will wait. Is there anyone to take me? If there is nobody is taking them, then they themselves will combine and form hydrogen gas. So what should be the our explanation? If the question comes, why iron forms FeCl2 instead of FeCl3 when it reacts with HCl? So what should you write? You'll write on the reaction of iron with hydrochloric acid, the nascent hydrogen which is produced, it reduces ferric chloride to ferrous chloride. All right. So this question is there. So let me write the question and you will write the answer by yourself because I have explained everything. So we'll keep this equation and I rub off this equation because this equation I did not get it from the blue. I have explained it. So why does iron form FeCl2 on reaction with hydrochloric? Okay. So please write this equation first. These two. Then we'll write.
Done, sir.
Okay. So you will write, you have written these two. This one you have written. This equation did you write?
Yes, sir.
Okay, then you write. The reaction of iron with HCl produces nascent hydrogen which reduces ferric chloride to ferrous. If the teacher doesn't believe, equation is there because it is not our imagination. It is an experimental proof. Now, can I remove it?
Okay, sir.
Okay. So now I see acid will react with base. So right now reaction with bases. So when HCl reacts with the bases, what will form? It will form the corresponding chloride salt. So suppose you have taken a sodium hydroxide, these are all Nursery equation. So you will get sodium chloride and H2O. Suppose you have taken calcium oxide, 2HCl, it will give you calcium chloride, water, salt and water. If you have taken sodium carbonate, bicarbonate, it will react with HCl to liberate what? Form what? Sodium chloride, H2O, and and carbon dioxide. If I have taken carbonate, if I react with HCl, so it will give me calcium chloride, H2O, carbon dioxide. If it comes in contact with ammonia, it will give you ammonium chloride. Okay, so I write with two more. Reaction with sulfides. This is not given in your book, but you should know. Reaction with sulfides. Say you have taken here sodium sulfide. See, valence of sulfur is 2, sodium is 1. So if it comes with react with HCl, just like the salt, what is going to form? It will form sodium chloride, and it is going to liberate H2S gas, dear, H2S gas. Similarly, if you have taken here ferrous sulfide, and if you react with HCl, it will give you ferrous chloride and H2S. Then reaction with sulfides and bisulfides. This we have done already in the preparation of sulfur dioxide. Remember, suppose if I have taken here potassium bisulfide, and if you add HCl, it will give you potassium chloride, H2O plus sulfur dioxide. If you have taken sodium sulfide, this is bisulfide and this is sulfide. SO3, 2HCl, it is going to give you 2 sodium chloride, H2O plus sulfur dioxide.
Yes, sir.
Okay. Now, hydrogen chloride is a reducing agent. Why it is a reducing agent? Just now I told you it gives you hydrogen. Huh? So, yes, reducing agent. Anything which gives oxygen is an oxidizing agent. Anything which gives any electronegative elements is an oxidizing agent. Anything which will give you hydrogen is a reducing agent. So all these equations I have done it for you. Remember, this is the equation for of preparation of chlorine that you've already done. See, when we are talking about chlorine, then we have mentioned that manganese dioxide has oxidized HCl. Now we are talking for HCl, then we'll say HCl has reduced manganese dioxide. Just like two sides are playing, supporters are there. If one of the party they win, they say we won. Other party will say we have lost. So loss is what? Oxidation. Gain is what? Oxidation is reduction. That's all. See, when we are talking about chlorine, we say manganese dioxide has oxidized HCl. And now we are a supporter of HCl. What will say? My HCl has reduced manganese dioxide. That is it. Now, suppose I have taken here KMnO4. Okay. And here if I write 16 HCl, remember this equation also have done it for you. So it is 2 KCl, 2 MnCl2, then 8 H2O plus 5 chlorine. How do you know it's being reduced? See, this is 4, this is plus 2. Reduction of positive oxidation state is called reduction. If the positive oxidation state decreases, then it is called reduction. See here, this is plus 7 and this is plus 2. So HCl has reduced KMnO4. This equation is important for you, this one. Okay, now for your information, this is a black powder and this is color. This is violet, this solution. This is color. Now I write one more. Potassium dichromate for your entrance exam. This is not given in your book. Your book is horrible. 14 HCl. So it gives you 2 KCl, 2 CrCl3, 7 H2O plus 3 Cl2. This is orange in color and this is green. Okay, so this is the one. Now we'll go for a very important one. This is called chromyl chloride test. This is an analytical, means experimental, analytical test performed to detect the presence of chloride, chloride, Cl minus. In laboratory, in salt analysis, you are supposed to do, because of the pandemic, so everything finished. Okay, this is the one. So what you do in this test, potassium dichromate or sodium dichromate is heated with chloride salt in presence of concentrated H2SO4 to liberate a reddish orange vapor. If the reddish orange vapor comes, then we know the salt is chloride. Due to the generation of chromyl chloride. What is the formula? CrO2 Cl. So I'll show you the equation.
Done, sir.
Okay. So these I was supposed to do in DNF block chapter, but still I'll do it for you. So what do you do here? Suppose I have taken potassium dichromate. So I have taken here K2Cr2O7 H2SO4. I heated it. Okay. So when I heat it, I get here potassium hydrogen sulfate. How many potassiums are there? 2. And here you get CrO3. How many chromium? 2. Okay. So let us see whether I balanced or not, because this equation I have done long time back. I may be wrong also. 2 potassium, 2 potassium. 2 chromium, 2 chromium. How many sulfate? It should be 2. Oh. So it is how many sulfate? 2. So what are the things I'm supposed to balance here? It is the oxygen and hydrogen. Now, how many oxygens are here? Here it is 7. How many are there? 6. See, how many out of 4 hydrogen, how many are here? 2. This is I have to balance 2 more hydrogen and 1 oxygen. I write now here H2O. All right. Now, so I have taken a chloride salt. See what is written there? Chloride salt. So let me write here chloride salt. So you know it very well that any chloride salt, if you heat it, what does it give? It gives you In case of sodium, it is going to form sodium hydrogen sulfate. In case of potassium, it is going to form potassium hydrogen sulfate. Okay, so you need not mark up this. Plus what? Huh? See here. So here I'll write 2. No, what should I write? Sorry. 1 potassium, 1 potassium. So now 1 sulfate, 1 sulfate. 2 hydrogen, 1 hydrogen. So it will be AC. Okay. Now see. Here we have CrO3. And it is this. What is it going to form? It is going to form CrO2 Cl. Don't get scared. So how many I require here? 2 hydrogen. See, 2 hydrogen. Out of 3 oxygen, 2 we have here. Out of 2 chloride, 2 we have here. So here we have 2 hydrogen and 1 oxygen left. It will be H2. All right. Now see, how many chromium are there? 2. I shall multiply the equation by 2. How many HCl you require? 2 into 2, 4. This equation gives you how many? 1. I shall multiply it by 4. Don't break your head. It's very easy. I'll add it. So see, everything is balanced. Each and every step I balanced. So now let us see. 2 CrO3, 2 CrO3. See, 2 into 2. 2 into 2, 4 HCl. Right hand side you have 4 HCl. This is balanced. So now we are going to add. Okay. So I'll write now. K2 Cr2 O7. This I will again do in DNA flow. Okay. Then see how many KCl? 4 KCl. How many sulfuric acid? 2 into 2 plus 4 into 4. So it is 6 H2O. Now I write in the right hand side. See here. 2 KHSO4 and 4. So it will be 6 KHSO. Okay. Then what is left out now here? This. How many? 2 Cr O2 Cl. And how many molecules of water? 2 and plus 1. So this is bromyl chloride. Reddish orange. I have done it intentionally because this chloride must be tested. Okay. So now we'll do one more. I'll see whether you can finish it on by next Thursday or not. I want to start because this month itself I have to do because potential chemistry I cannot go fast. October I have to start organic. Otherwise, October, November, December. If otherwise, so one because December I'll go. And we started very, very late. Next Sunday, you are going to have extra class. I think. बाकी तुम्हारा DSL बाकी तुमको I think you're doing that. You're doing that. अभी ओप्पो पे फोन निकला है उसका 128 दूंगा भाई microscopic thing.
Done, sir.
Okay. So now we'll go for a very important topic. It's called aqua regia. Aqua means what? Water. And regia means what? Regia. Any idea? See, the word regia is being taken from the word called regal. Have you heard the name of regal? Huh? Hello.
No, sir.
Have you heard the name of regal?
No, sir.
গীতাঞ্জলি তোর বাড়ির সামনে রিগেল রেস্টুরেন্ট আছে?
Yes, sir. I heard of the restaurant.
Then where from the word regal has come? You never know. You never try to know.
I don't know.
Regal means royal. So aqua regia means royal water. Water is water. How can you have poor man's water and king's water? Huh? So I'll explain it later on. See, would you write now? It is a mixture of three volumes of concentrated hydrochloric acid and 1 volume of concentrated nitric acid. This is called aqua regia. It is very strong. It even dissolves noble metal like gold and platinum. Gold and platinum cannot be dissolved by any acid. Of course, gold can be dissolved by selenic acid. That is something different. Otherwise, they are not soluble. So what is the secret? You can write here now. It is so strong that it can even dissolve noble metals like gold and platinum. Why? What is the secret behind this? So I'll write down the equation. HNO3 plus 3HCl. Concentrated. It gives you 2H2O, NOCl plus 2 chlorine. It gives not chlorine molecule, it gives you chlorine atom, which you call it nascent chlorine. What is the name of this NOCl? It is called nitrosyl, NitroSyl. Nitrosyl chloride. And this is what? Nascent chloride. Okay, so now I'll write Then why noble metal reacts? Right. It is the nascent chlorine atom which reacts with noble metal to form soluble for water soluble chloride salts. So now we'll do reaction. Okay. So now we'll write reaction with gold. So first I'll write gold is what? A. So I'll write now here 3 HCl plus HNO3 2H2O NOCl plus 2 chloride. Then I'll write here now gold AU NOCl 2Cl. It gives you AuCl3 plus nitric oxide. This is called auric chloride. Auric chloride. But this auric chloride is not stable. Auric chloride immediately reacts with another HCl molecule to form H AuCl4. This is a coordination compound. I'll add it. See here. NOCl, NOCl cancels. 2Cl, 2Cl cancels. AuCl3, AuCl3 cancels. So I'll write now the final equation. Au 3, it's not 3 HCl, 3 plus 1, 4 HCl. 4 HCl plus HNO3. So it will give you HAuCl4 plus 2H2O plus this. Okay. So this is called AuRic, auric acid. Why? because if it water dissociates as H plus and AuCl4 minus. All right. This equation may not match with your textbook equation because this is the original equation. So, and this is called what? Nitric oxide.
Done, sir.
Okay. So now we'll do it platinum. I'll try to do it here, then you'll understand. Reaction with platinum. Okay. So now all this thing I'll remove. So I'll remove this. I'll remove this. I'll remove this. Okay. See here now. So this is the one which is going to form. So now I'll take here platinum. See, gold forms AuCl3, platinum forms PtCl4. PtCl4. So now you cannot balance. In case of gold, you had 2 chlorine, 2 plus 1, 3. So it was easy for us to do it, but it is PtCl4. So how to balance this one? We'll go for cross multiplication. Here we have 3 and here we have 4. So 4 into 3 is 12. So we'll go for cross multiplication. So I'll write now here 4 platinum. So I'll write now here 4. So 4 platinum. How many chlorine I require? 4 plus 4 into 4 is 16. It gives you 2 and it gives you 1. This is 1:2 ratio. So 4 into 4 is 16. So now how to balance? Wait. So no. I write here. Because I told no, I'm going to for cross multiplication. So I should have multiplied by 3 only. 3, it is 3 and it is 4. So I'm a fool. I should have multiplied by 3. I'll write now. Yeah. So 3 into 4, 12. That is 12 chlorine has to come from here. What is the ratio now? 1:1:2. So 12 if I divide by 4, how much it comes? 3. So I'll write now here. So here I'll write here. It will be 8 and it will be 4. See, 4 plus 8 is what? 12. So this is has to be supplied by whom? By this equation. So if I multiply this by 4, how much it comes? See, is it not 12 now? See, 1 plus 2, 3 into 4, 12. Now we have got this one. See here, 4 NaCl, 4 NaCl, 8 Cl, 8 Cl. Okay? So now you have got this one. So this platinum tetrachloride, just like gold, is not stable in acid. So what happens now? PtCl4 reacts with 2HCl to give you H2PtCl. How many are there? 3. So I shall multiply it by. Okay. So now I remove the whole equation. So now it comes. See here. This get cancelled. This get cancelled. See, 3. So I'll write now here 3 platinum. How many HCl dear? 4 into 3, 12. 3 into 2, 6. So 12 plus 6 is 18. 18 HCl. Okay. So I'll write now in this side 3 into H2 PtCl6 plus how many molecules of water? 4 into 2, 8 molecules of water. All right. Now, how many NaCl? See, this I forgot to balance. Is 4? No, it should have been 4. It will be 4. 10. This is called platinic acid.
বালতির থেকে না আছে তো পরে কোনো পরে দেবো বাস থাকলে জলটা ফিল্টারটা তাড়াতাড়ি ঠিক আছে ঠিক আছে করে দেবো
Finished?
Yes, sir.
Then why you are keeping quiet? Taking rest or what? What's up with you? Hi.
Sir, I just finished just now.
Acha. I thought you'd be tired. And most of the other students who are attending my class, so they are almost deaf and dumb. They cannot speak. I don't know whether they attend the class or they keep this mobile on and maybe they hang around. Okay, now we'll go for oxo acids of halogen. What is oxo acids? Oxo acids of halogen means, see, HCl, HBr, HI, these are hydracids because along with the halogen you have hydrogen. But if the acid molecule contains hydrogen, halogen, and oxygen, then we are going to call it oxoacids of halogen. Okay? So we can write down here. Halogen form different oxo acids with oxidation state from +1 to +7. So I'll write down what is their name. Okay. Suppose it is HOF. So these are called Hellas acid. Hellas acid. Suppose it is HOCl, we call it, sorry, not Hellas, hypohellas acid. We call it hypohellas. So one we have already done. If it is HOCl, we call it hypochlorous acid. Then HXO2, we call it Hellas acid. Like chlorous acid, bromous acid, Hellas acid. Okay. If it is HXO3, we call it halic acid, like HClO3. We call it chloric acid, bromic acid, iodic acid. And if it is HXO4, we call it perhalic acid. Okay, on the top of the halogen, I'll write down this oxidation. So this is +1, this is +3, this is +5, and this is +7. Okay, +7. So we'll write now. So at some point I'm going to write. We'll write here fluorine, FLURINE. Fluorine only forms HOF, means what? Hypofluorous acid. FLOUROUS. This is for your entrance. Only form hypofluorous acid, which is highly unstable and decomposes. So please remember, this is the only acid formed by, only oxyacids formed by fluorine. This is for your entrance exam. While the other halogen forms almost all the acids. Okay. Second, the acidity of the oxoacids increases with increase in their positive oxidation state. Okay, example that what is example is what? See here. HOCl is less acidic than HClO2, HClO3, and HClO. This is the HClO. So again, I'm telling you name: hypochlorous acid, chlorous acid, chloric acid, perchloric acid. Okay, I'll write down. Today I'll have to finish early because I have one more meeting in there. So what is this? Hypochlorous acid. This is chlorous acid. This is chloric acid, and this is perchloric acid. So I'll just take 2 minutes time to draw their structure. See here. So these are all the lone pair of chlorine which did not combine. So this you cannot see. 3 of them you cannot see. So this is H+. Then these are the lone pair which you cannot see. This is HClO2. Then this one you cannot see. It is HClO3. These structures are important for your exam. It is HClO. So with this, I finish. Please draw the structure, patapat, because one more meeting is there at 6:30.
Done, sir.
Okay then. Bye for today.